Today we're going to look at the conic section, circle. Now circles are pretty straightforward because they don't have a lot of extra things that we haven't talked about before, and there's only one form of the equation. We've got an x minus h squared plus a y minus k squared equals r squared. And there's only two characteristics we're going to pull out. We're going to pull out the center, which is the h and the k, and we're going to pull out the radius. Now this is the one that sometimes trips people up because they have to make sure they square root whatever number is sitting over here on this other side. Now an interesting thing about circles is they're actually derived from the distance formula. The nice thing about circles is every point on a circle is the same distance from the center. That's where we get the term radius, but it's all built off of this distance formula. And we may need this in one of our calculations today. We'll start off really simple. We'll talk about an example that has a center and a radius given, and they want us to write the equation. So I'm going to write x minus h squared y minus k squared equals r squared, and I'm just going to fill in the things I know. Now the center, h and k go in the parentheses. Now we're dealing with parentheses again, so things are backwards. So when I put the negative 4 in here, this becomes a plus 4. When I put the 3 in here, it becomes a minus 3. And the thing I have to remember on the other side, I take the radius, but I square it. That's something I forget. Some people will write it as 16. Some will actually write it as 4 squared so they can look and see the radius in the way it's written. If they instead give me the whole equation and ask me to pull out those pieces, this is centered at 16, negative 9. Notice I changed the signs when I pulled them out. And if I square root this 144, this has a radius of 12. So they're going to do a little of both, giving you the equation or giving you pieces. So on this one, they gave me the equation, the center, negative 1, 3, with a radius of 5. The other thing that we're going to do with these is we're going to move them around a little bit. Notice that the center on this one was moved, the center on this one was moved, but this one is centered at 0, 0. So right now we're centered at 0, 0 with a radius of 3, but they want me to move that. The way I do that is I take the same form and I put those in the right places. Now, this is where I have to be careful. Left 4, that's a minus 4. But when I put that into my parentheses, it's actually a plus 4. And an up 3, which is positive, in parentheses, is a minus 3. So I took this same circle, same radius of 3, and I moved it left 4 and up 3. They also will give you examples like this, where they give you the center, but they don't give you the radius. So I have the center here, it's at 4, 3, but they gave me this other point, and they didn't give me the radius. This is where I go back to that distance formula, because I need to know how far it is from here to here, and since the radius is the same everywhere on this circle, if I can find that distance, I actually have the radius. So I'll start with what I've got. I know that this is x minus 4, and I know it's y minus 3. The only thing I'm missing is the radius. But if I go back to this distance formula, it says the difference in the x's and the differences in the y's. So difference between the x's here is 4. The difference between the y's here is 3. I'm supposed to square those, add them up, and square root them, and I will have the distance. So I have 16 plus 9, that's 25. So that means this distance is 5. 5 squared, or I could put the 25 in there. Now I know what my radius is. And that's all there is for the conic sections on circles.